First question is, if we have risks, like risks are probabilities, why do we need the odds? Is that necessary as risks are more rigorous and sophisticated? Then why do we need the odds?
Thanks for that question, Aphrodite. Well, because I guess that boils down to the data that we have. For risk, what we need is the number of people at risk. That's why in most prospective studies, since we have that data, we report the risk. We report the risk ratio. But for some other study designs, we don't have that number, and so we rely on other statistic, which is the odds ratio.
Thank you. The second one, collecting dichotomous data may not be possible if we're interested in adjusted effect size. How to solve this if we're interested in adjusted estimates?
Sorry, can you say that again, Aphrodite?
Collecting dichotomous data may not be possible if we're interested in adjusted effect sizes. How to solve this if we're interested in adjusted estimates? I guess the question is, if we want adjusted data, but the studies provide non-adjusted data, what do we do?
Well, I guess that's actually a separate topic of its own, meta-analyzing adjusted data. In standard meta-analysis, what we combine are unadjusted data. And actually we cannot, it's a separate issue on its own. We cannot really combine unadjusted and adjusted data because it's a different model. And I guess it's just hard. To be honest, I don't know the answer to that, the appropriate answer to that, but perhaps Aphrodite or other people might have insights to that.
This is a different topic, to be honest. But yeah, if researchers are interested in adjusted data, then they should seek the adjusted data, and if not, they're not available, then they can use the raw estimates, I guess.
And I guess for adjusted data, you would probably need the individual level data to adjust for the factors that you want to include in your analysis. Yeah. And in meta-analysis, this is really quite tricky because different studies would adjust for different factors. And that in its own is an issue. So for example, a study reported an adjusted estimate adjusting for age and sex, but the other study reported an adjusted estimate adjusting for age, sex, BMI, education. And it's a question whether it's okay to combine these two or not. So I guess it's really hard to combine adjusted estimates.
Okay, so the next question, can you please also explain how hazard ratios are different from risk ratios?
Okay, a short answer to this is it's a different denominator. So for hazard ratio, we are talking about person time. So, and here it's much stricter. So this is definitely, you get this value if the design is prospective, because in a way you are able to measure how long a person has been exposed in the intervention. So the denominator is person time. So it's a different one.
The next question, does this method in dichotomous outcomes works when we convert continuous into dichotomous outcomes, like percentage into cutoffs?
Ooh, that's another issue. Well, studies would report the aggregate data, right? And so it would be hard to really. So if the study reported continuous outcome and you just have an aggregate continuous outcome data, then it might be impossible for you to use these cutoffs. What we need to do that is probably the individual level data again.
So the next question, so I don't have to use the number of participants randomized as the denominator of a binary outcome when performing an intention to treat analysis.
Well, again, it depends. You have to use your judgment and decide if it's reasonable to use to do an intention to treat analysis or per protocol analysis. But in general, we do some sensitivity analysis, doing both intention versus per protocol. And of course, you have to include this in your protocol from the get-go.
Okay. The next question, How is the minimally or clinically important difference decided?
For continuous outcomes, it's easier to compute minimally important differences. I think there's some people working on some calculations on how to calculate minimally important difference for continuous outcomes, but not all outcomes would have these thresholds at the moment. For dichotomous outcomes, it's much harder.
The next question, out of 4 studies using different scales, for which study do we calculate the standard mean difference? Is it for each study? I think you explained that, Joseph.
Yeah, that's for each study, because we want to convert all the studies into a common metric, which is in standard deviation units.
Okay. And the last question, what is the difference between difference in means and mean difference?
Difference in means and mean difference?
I think it's the same.
Yeah, I think so.
Interchangeably. Yeah, there's no difference between them. Yeah.